For these last 8 questions of the 8.1 to 8.3 review, we're going to be graphing exponential equations. And I'm going to write out what we want to remember here. I should say exponential functions. We're going to graph 3 points. And those 3 points are 0, 1, 1, and whatever the base is, and then -1, the reciprocal of the base. All right, so we're going to graph those points. And then we're also going to remember that for the parent functions, the x-axis is a horizontal asymptote. All right, so let's do number 19. We want to graph 3 points. We want to graph the point 0, 1. 0, 1. Then we graph the point, I'm going to come over here. So we're going to graph the point 0, 1, 1, whatever the base is. The base in this case is 3. And we'll graph -1, the reciprocal of the base, which is 1/3. So 1, 3, -1, 1/3. And I'm going to squeeze this in our directions here. Other points, if helpful. So we can put in a few other points if we want to. What happens if we put a 2 in there for x? Well, we get 3 squared, which is 9. If you put a 3 in there for x, you get 27, which is not on our graph. So not real helpful here for the 27. And then we remember the x-axis is a horizontal asymptote, and so our graph gets closer and closer to that asymptote and then follows the points over here. And we have, now it shouldn't cross over 3 here because we know we don't get to 3 until it's going to hit 27. So it looks something like that. All right, number 20. Our points are 0, 1, and this is just for the parent function. This has this -1 here, which we'll have to work with after we graph our parent function. So if you remember, we're going to do kind of this in 2 parts. We'll do the parent function, and then we'll move it around to find the actual graph of the function that we have here. So 0, 1, 1, the base, and then -1, the reciprocal of the base. Maybe another point you plug in 2. You plug in 2. So 4 squared. 4 to the second is 16. So this is just for the parent graph. We're neglecting this -1 for right now. So we have -1, 1/4, 0, 1, 1/4, and 2, 16. And we have a horizontal asymptote. So here is the parent function before it shifted because of the -1. And I kind of just gave away what's happening there. So now for our actual function, we will do in yellow, we're subtracting 1 inside the exponent. Inside the exponent. So that means it moves left or right. So it moves right 1 here. So what we do is we take each point and move it right 1. So I'm going to move -1, 1/4 over 1. I'm going to move 0, 1 to the right 1. 4, 1. 1/4, and 216. I'm moving everything right 1. Even the asymptote can get moved right 1, although moving a horizontal line to the right 1, it doesn't look any different. And so the yellow is our solution. Okay, number 21. Again, we can start off with our parent function. We have 0, 1. 1, the base, which is 2. Negative 1, the reciprocal of the base, which is 1/2. Since 2 is a pretty small base, we probably can do some other ones here. So 2 squared. So putting a 2 in here, remember we're just doing the parent function. So maybe I should just write that y equals 2 to the x is what we're talking about here. So 4, 3, put a 3 in for x, 2 to the third, you get 8. 2 to the fourth, 2 to the fourth, you get 16. So actually this one we could fit a lot of points on there for our parent function. We have our main 3 that we've talked about. But then we have 2, 4, and 3, 8, and 4, 16. So that's the parent function. In orange, there's a horizontal asymptote at the x-axis. Now we're adding one outside of the exponential. We're not adding 1 to x, we're adding 1 to 2 to the x. This is going to move our function up 1. So our actual function we will do in blue, and we're going to move every point up 1. And our horizontal asymptote moves up 1. Everything moves up 1. And so the blue is the graph of that function. Number 22, I'll leave for you to do on your own, but after you do the parent function, you're going to go left. Each point's going to move left 2 and up 1. 23 through the end, they're still the same. They just have fractions in here. So we remember if we have fractions, this is going to be exponential decay. Our parent function, in this case, is the actual function because there's nothing added there. We have 0, 1. We have 1, the base. So the base is 1/3. And we have negative 1, the reciprocal of the base. The reciprocal of 1/3 is 3. And so we notice that instead of going up from left to right, we're going to go down from left to right. So our horizontal asymptote is going to be over here on the right side. If we think through this, we should realize that, so if negative 1 gave us 3, negative 2 is going to give us 9. So we can put in another point there if needed. And there's the graph of y equals 1/3 to the x. And we'll do one more, and I'll leave the last couple for you guys to do. Our 3 points are 0, 1, 1, whatever the base is. This is the parent function again. Probably realizing we're going to move the whole thing up 2. 1, 1/2, negative 1, the reciprocal of 1/2, which is 2, which means negative 2 is going to give us 4. Negative 3 is going to give us 8. Just so you remember, I'm writing these down like you know them, but if I think 1/2 to the negative 3, that means 1 to the negative 3 over 2 to the negative 3. But in the past, we learned negative exponents move the base. So it's 1 to the third, but it moves to the denominator. 2 to the negative 3 in the denominator moves to the numerator, which is 2 cubed. And so this is 8 over 1, and that's how I'm getting this here. So here's our first two main points, 0, 1, 1, 1/2, and negative 1, 2. I gave you a few other ones there. We could actually go negative 4, 16. That is the parent function with the horizontal asymptote at the x-axis. However, we're going to move this parent function up 2, so my answer is going to be in green. I'm moving everything up 2 units. The asymptote also moves up 2 units. And we can graph y equals 1/2 to the x plus 2.